In this video, we'll have a discussion about data correlation and analytics. One aspect of securing the enterprise is to monitor IT systems and their resultant data, and there are plenty of tools that can do that in various ways. It's also important not just to gather that type of data, but to analyze monitoring data to try to extract meaning from what we've got. Now, analysis could be historical, where we want to identify trends over time. So we might want to aggregate data from different sources taken over time, and we might even want to correlate it with current data. So real-time data can also be used, and that's really useful when we need to identify suspicious activity that could indicate that there's some kind of an exploit being taken advantage of. Of course, when we secure the enterprise and look at all this monitoring data, we need an efficient way to run reports on only the extracted relevant data. There are also data retention laws and regulations that could apply to an organization that determine how long data gets stored. In order for data correlation and analytics to provide relevant information, our network device inventory needs to be up to date. Now, we can't manually run around and write down what we have on a large scale. Instead, we should use a centralized automated solution such as Microsoft's System Center Configuration Manager, otherwise known as SCCM. There are other tools from other vendors, including Altiris and Spiceworks. Either way, we need a way to track what is on the network. In this day and age, there's lots of talk about big data. Well, one aspect of that can become complex is the analysis of big data. So we need to have a solution that is scalable if we're going to be monitoring information on a large network or on multiple networks with thousands of devices. Now, one of the things we could use is a cloud-based service where we could spin it up as we need to do the analysis and then spin it down when we no longer need it. That way we're not paying for it when it's not in use. So an example of this would be Amazon Web Services' Elastic MapReduce tool. So essentially, we've got a cluster of devices processing very large data sets so that we can extract only useful information. Now, big data analytics can also involve real-time analysis of network traffic, which gets a little more complex if we want to analyze it as it's happening. Deep packet inspection is possible, where we look further beyond the packet than its headers. Instead, we're looking down into the payload or the data portion of the packet to determine what's happening or if there's something suspicious happening. Large volumes of device monitoring data sets will be able to benefit from the fact that we might have a cluster of machines working together to analyze the data, such as is the case with Elastic MapReduce. We also have to consider the fact that big data analysis might require correlation of differing data sources. So depending on the solution that we use for big data analytics, we might be able to accommodate different types of data sources, or one system might have to export it in a certain format so it's in a consumable form by another big data analytics solution. When we talk about big data, we have to consider how much storage space will be required, especially if we've got retention requirements where we've got to keep data hanging around for a long period of time. So we always have to think about the current amount of required space, but also we need to think about future growth and capacity planning to make sure we don't run out of space. And that's one case where the cloud comes in useful, where we can rapidly provision additional disk space as it's needed. We should also consider the use of data duplication. In this way, we're only storing one copy of unique disk blocks, and in the end, we're conserving disk space. Data correlation and analytics becomes extremely useful when we generate useful reports. As they say, a picture paints 1,000 words. So if we have reports that can be generated in some kind of graph format, then people that are decision makers can quickly ascertain by looking at the graph what's happening and then make a decision based upon it. However, for that to work properly, the reporting data must be trustworthy. Also, the data must be current if we're looking at making new decisions based on that data. We can also integrate our data correlation and analytics solution with intrusion detection and prevention policies to identify anomalies. So essentially, we are reusing existing configurations, since there is some overlap in what the possibilities are in terms of detecting anomalies. Another aspect is to make sure that we configure our solution such that it will filter out false positives. A false positive is some kind of event that gets triggered where it may look, for example, on the security side, as some kind of suspicious activity when in fact it's benign and normal activity. And this is one of the reasons why many of these security solutions need to be tweaked. They need to have very specially crafted rules that are specific to an environment. Data correlation and analytics also has the benefit of being able to determine some kind of a response to discovered security incidents. In this video, we discussed data correlation and analytics.